today we are doing a single replacement lab, and through this lab we should be able to start figuring out why some single replacement reactions work and why others do not. And this all has to do with the placement of the cations on something called our activity series. So we'll worry about the activity series in just a little while, but today we want to do 4 different reactions. So the instructions that you got were write formulas for the reactants with states of matter, describe each reactant, then you want to actually perform the reaction following these instructions right here. Then you want to describe each product and write formulas for the products. So what I would like for you to do is first go ahead and cut these in half, just the ones on the reactant side. And what we're going to do is we're going to write the formulas for our reactants. So the first one says that we have copper 2 sulfate with zinc. So we know that copper has a +2 charge as told us in here. And sulfate has a -2 charge if we were to look on our reference packet. And we're reacting it with zinc. Reaction 2 says aluminum reacts with copper 2 chloride. So we have Al plus CuCl2. Then we have sodium chloride reacts with tin. So we have NaCl with tin. And then reaction 4 says hydrochloric acid reacts with zinc. So we know hydrochloric acid is HCl, and then we have zinc. So the next one says describe each reactant. So here I have a whole bunch of different solutions, and what I would like for you to do is write a description in the box. So this right here is a see-through solution, and it does have a blue tint, and this is copper sulfate. This right here is a piece of zinc. It's silver in color. It is metallic. It has a irregular shape, and it is a solid. Next we have aluminum. This right here is aluminum. Again, it's silvery in shape. This one is more of a ball, and again, is solid. And that one is reacting with copper 2 chloride, which is right here. Should have a very similar description to copper sulfate. Then we have NaCl, which is a clear, colorless solution. And we are reacting that with tin. Which looks like that. And then we have hydrochloric acid, which right now is in this bottle, but it's a clear, colorless solution as well. Now, anything that is not water that looks like a liquid, we're going to put AQ next to. AQ means that it is a solid that has been dissolved in water, and so it's a solution. Anything that is physically a solid, that we were able to hold it, we would put an S next to it. The only time that we're going to put an L next to it for liquid is if it's actually water. So now what we're going to do is we're actually going to do these reactions. So I'm going to do them for you. We already have our descriptions, and now we'll get to see our products. So the first one that I'm going to do is place a small piece of zinc into the well plate. That was a little too big, that's not going to fit. Okay. And it says put copper sulfate in there. Then the next one is aluminum with copper chloride. And then we have tin with NaCl. And let's pause right here. Let's look at what's going on. We, let's see, our zinc turned from that silvery metallic color to a really, really dark reddish orange color, red. Our aluminum in the copper chloride is now fizzing, and the solution is changing colors. It was once blue, and now it's greenish. And it looks like our aluminum is changing to a reddish color now. And it doesn't look like anything is occurring in our tin and sodium chloride. The next one we're going to do is our hydrochloric acid one. We're actually going to do that in a test tube because we're dealing with acid, so we have to be a little bit careful. So this one says to put in hydrochloric acid. So you can see how it's just a clear colorless solution. And now we're going to put in our piece of zinc and look to see what happens. Already we can see that bubbles are being formed. So there is definitely a reaction that is occurring. So what you want to do is you want to write down all the observations you saw for these different reactions. You can even hear this one bubbling. So again, this is reaction 1, reaction 2, reaction 3, and reaction 4.